Why can't we leave the solar system? On a clear night, the stars seem close enough to touch. For thousands of years, humanity has looked up at the sky and wondered what lies beyond. We built telescopes that revealed distant galaxies. We landed astronauts on the moon. We sent robotic explorers to Mars. Our spacecraft have visited every major planet in the solar system, and today, we can photograph black holes billions of light years away. It feels as though humanity has conquered space. But there is one astonishing fact that changes everything. Not a single human being has ever traveled beyond the moon. Not one spacecraft carrying people has ever come close to leaving our solar system. In fact, even our fastest robotic explorers are still only beginning that journey. Which raises an extraordinary question. If our technology is powerful enough to explore the planets, why can't we leave the solar system? The answer begins with something our brains struggle to understand: the true size of space. Imagine shrinking the sun until it is the size of a large front door. On that same scale, Earth would be smaller than a pea. It would orbit nearly 150 meters away. Neptune, the outermost major planet, would circle almost 5 kilometers from the sun. And beyond Neptune, there is still an enormous ocean of empty space. Most illustrations of the solar system are misleading. To fit everything onto a single page, planets are drawn much closer together than they really are. In reality, space is exactly what its name suggests: space. Vast, silent, almost unimaginably empty. If you could drive a car to the moon at highway speed without ever stopping, the journey would take nearly 6 months. Driving to the sun would require well over 170 years. Driving to Pluto would take thousands of years. And Pluto is still inside our solar system. The distances become so enormous that ordinary units like kilometers begin to lose meaning. Astronomers needed new ways to measure the universe. The Earth sits about 1 astronomical unit from the sun. That sounds simple enough, until you realize 1 astronomical unit equals nearly 150 million kilometers. And even that enormous distance is tiny compared to what lies beyond. Far outside the planets exists a vast region filled with icy objects left over from the birth of the solar system. Beyond that may lie the mysterious Oort cloud, a gigantic shell of frozen bodies thought to surround the solar system in every direction. If it truly exists as scientists believe, its outer edge may stretch nearly 2 light-years from the sun. That means our solar system is far larger than most people imagine. But perhaps the greatest symbol of humanity's journey into deep space is a spacecraft no larger than a small car. Voyager 1. Launched in 1977, its original mission was surprisingly modest. It was designed to study Jupiter and Saturn before continuing onward into deep space. No one expected it to become humanity's most distant messenger. Nearly 50 years later, Voyager 1 is still traveling. Every second, it moves through space at roughly 17 kilometers per second. That sounds unimaginably fast. And by everyday standards, it is. Yet on the scale of the universe, it is almost motionless. Even after traveling for decades, Voyager 1 has only recently entered interstellar space, the region beyond the sun's protective magnetic influence. But here's the incredible part. Leaving the sun's magnetic bubble does not mean leaving the solar system entirely. The sun's gravity continues reaching far beyond Voyager's current location. Some scientists estimate it could take the spacecraft tens of thousands of years before it truly escapes the distant Oort cloud. Think about that. A machine traveling faster than a rifle bullet for tens of thousands of years, just to leave our own cosmic neighborhood. Voyager 2 follows a different path. Launched only weeks after Voyager 1, it explored Jupiter, Saturn, Uranus, and Neptune before continuing outward. Together, these 2 spacecraft carry humanity's first messages intended for whatever may exist beyond our solar system. Attached to each probe is a golden record, a gold-plated copper disc containing sounds and images from Earth, greetings spoken in dozens of languages, music from different cultures, the laughter of children, the songs of birds, the sound of rain, even the heartbeat of a human being. It is a message in a bottle, cast into an ocean so vast that it may drift for millions of years before anyone, or anything, ever finds it. And that reveals another astonishing truth. Space is not just big, it is unimaginably empty. Voyager could travel for thousands of years without coming anywhere near another star. The nearest star beyond our sun is Proxima Centauri. Its light takes more than 4 years to reach Earth. That means even traveling at Voyager's incredible speed, the journey would require more than 70,000 years. Longer than all of recorded human history. longer than civilization itself. The challenge is no longer building a spacecraft. The challenge is overcoming distance. Every planet we have ever visited, every moon we have ever photographed, every comet we have ever explored, exists inside an incredibly tiny corner of the universe. Our greatest achievements in space are extraordinary, but compared to the true scale of the cosmos, they are only our first few footsteps. Which raises an even more difficult question. If distance is the greatest obstacle, what would it actually take for humanity to travel beyond the solar system? And are the laws of physics themselves standing in our way? For more than a century, science fiction has imagined humanity traveling effortlessly between the stars. Massive starships glide through the darkness. Crews awaken after crossing unimaginable distances. Entire civilizations spread across the galaxy as if space were nothing more than another ocean waiting to be crossed. Reality is far less forgiving. The greatest obstacle standing between humanity and the stars is not a lack of courage. It is physics. Every spacecraft ever launched from Earth obeys the same fundamental laws of motion. To travel faster, you need more energy. To carry more fuel, your spacecraft becomes heavier. A heavier spacecraft requires even more fuel to accelerate. That extra fuel adds even more weight. Engineers call this the tyranny of the rocket equation. It is one of the most unforgiving problems in aerospace engineering. Chemical rockets, the technology that carried astronauts to the moon and launched probes across the solar system, are incredibly powerful. But they are also surprisingly inefficient for interstellar travel. Most of a rocket's mass at launch is fuel. Only a tiny fraction becomes the spacecraft itself. And even then, the speeds we achieve are tiny compared to the scale of the universe. To truly appreciate the challenge, imagine shrinking the distance between Earth and the Sun to just 1 meter. On that same scale, the nearest star would still be more than 270 kilometers away. Everything we have ever accomplished in space, every satellite, every mission, every landing, has taken place within that first single meter. The rest is almost entirely empty. Scientists have proposed many ways to cross those unimaginable distances. One possibility is nuclear propulsion. Instead of relying solely on chemical reactions, future spacecraft could harness the tremendous energy released by nuclear fission or even nuclear fusion. Such engines might dramatically reduce travel times within our solar system. A journey to Mars that currently takes months could eventually be completed in weeks. But even these powerful systems would remain painfully slow on the journey to another star. Another idea is the solar sail. Rather than carrying enormous amounts of fuel, a spacecraft would deploy an ultra-thin reflective sail stretching hundreds of meters across. Tiny particles of light emitted by the sun exert an incredibly small force. Normally, it is almost impossible to notice, but over months and years, that constant push could gradually accelerate a spacecraft to remarkable speeds. Several missions have already demonstrated that solar sails work. The concept is no longer science fiction, it is real engineering. Then, there are proposals that sound almost unbelievable. Powerful lasers stationed on Earth could fire concentrated beams at miniature spacecraft equipped with reflective sails. The light itself would accelerate these tiny probes to a significant fraction of the speed of light. A mission like this, known as Breakthrough Starshot, remains experimental, but it represents one of the boldest ideas ever proposed for interstellar exploration. If successful, a spacecraft no larger than a postage stamp could one day reach another star within a human lifetime. Even more ambitious concepts involve fusion engines, antimatter propulsion, or hypothetical technologies that exist only on paper. One of the most famous is the warp drive. Inspired by science fiction, physicists have explored whether space itself could, in theory, be manipulated. Instead of moving a spacecraft faster than light, the idea suggests compressing space in front of the vessel while expanding it behind, effectively carrying the spacecraft inside a moving bubble of space-time. Remarkably, mathematics allows certain solutions that resemble this concept. But there is an enormous problem. They require forms of energy and matter that have never been observed in the quantities needed. For now, warp drives remain fascinating ideas, not practical engineering. And then there is the greatest speed limit of all, the speed of light. According to everything modern physics has confirmed, nothing carrying information can travel faster than light through space. Light itself moves at nearly 300,000 kilometers every second. It circles Earth more than 7 times in a single second. Yet, even at that incredible speed, sunlight takes over 8 minutes to reach our planet. A message sent to Neptune requires hours. A signal from the nearest star takes more than 4 years. The farther we look into the universe, the farther we look back in time. When astronomers observe a galaxy 1 billion light-years away, they are not seeing it as it exists today. They are seeing light that began its journey a billion years ago. In a very real sense, every telescope is also a time machine. Perhaps that is the most humbling realization of all. The universe is not built on a human scale. It does not care about our lifetimes. Stars are born over millions of years. Galaxies evolve over billions. Distances that seem impossible to us are simply part of the ordinary fabric of the cosmos. And yet, humanity has never accepted impossible for very long. 100 years ago, crossing the Atlantic by airplane seemed extraordinary. Walking on the moon appeared impossible. Landing reusable rockets sounded like fantasy. Today, each of those achievements is part of history. Every generation inherits limits. Every generation pushes them a little farther. Perhaps one day, children will grow up watching the first images sent back from another star system. Perhaps the descendants of our civilization will step onto worlds that today exist only as tiny points of light in the night sky. Or perhaps the first explorers will not be humans at all. They may be intelligent machines carrying our knowledge, our history, and our curiosity across the darkness, long before we can make the journey ourselves. For now, however, humanity remains a young civilization standing on the shoreline of a cosmic ocean. We have launched a handful of small vessels into the darkness. We have taken our first cautious steps beyond our planetary home. But the greatest voyage in history has not yet begun. The stars are not unreachable because they are hidden. They are unreachable because the universe is unimaginably vast. Perhaps the greatest barrier is not technology, not fuel, not engineering. It is patience. The kind of patience measured not in years, but in centuries. Not in centuries, but in civilizations. And maybe that is exactly what makes the dream so extraordinary. Every great journey begins with a single step. Our first step carried us to the moon. Our second reached the planets. Voyager carried our name into interstellar space. The next step may one day carry humanity beyond the solar system itself. Until then, every distant star remains both a destination and a reminder. The universe is far larger than our imagination, yet curiosity has always been even larger. And as long as we continue asking what lies beyond the next horizon, our journey through the cosmos has only just begun.